What happens if lines are not parallel with transversals? Imagine drawing two lines across a sheet of paper and then adding a third line that cuts through both. If those two lines are not parallel, everything about the angles they form changes. When a transversal intersects two lines that are not parallel, the special angle relationships we usually see with parallel lines do not happen. For example, with parallel lines, corresponding angles are always equal. But if the lines are not parallel, these angles can be different. The same goes for alternate interior angles. They are equal only when the lines are parallel. When lines are not parallel, these angles no longer have a predictable relationship and can vary in size. This means the rules we use to prove lines are parallel, like equal corresponding angles or supplementary consecutive interior angles, do not apply anymore. The angles created by the transversal still exist, but they do not follow the neat pattern seen with parallel lines. For example, the angles on opposite sides of the transversal inside the two lines are not necessarily equal, and the angles outside the lines do not add up to a straight line of 180 degrees. This breakdown happens because the key reason for these angle relationships is that parallel lines stay the same distance apart and never meet. When lines are not parallel, they either cross at some point or diverge, which causes the angles to change. So, the angle theorems that depend on the lines being parallel, like the fact that corresponding angles are equal or alternate, interior angles are congruent, no longer hold true. In real life, this is why you can tell if lines are parallel just by looking at the angles they form with a transversal. If the angles are equal or supplementary in the expected ways, the lines are parallel. If not, the lines are not parallel. This is a handy way to check and solve problems in geometry. It also shows why understanding these angle relationships is so important in proofs and in figuring out whether lines are parallel or not. When lines are not parallel, the angle relationships change, and that helps us understand the geometry of the situation better.